So with this presentation, you can follow along. We are going to fire up FLAC2D, and we're going to just take pieces from this presentation, paste it into FLAC2D, and run it. See what happens. Okay, so we'll start here. If you don't have FLAC2D already fired up, that's fine. Go ahead and fire it up. I'll just continue with this one I call gg.py. It's right there. My console is kind of a mess. It has some invalid syntax. The hard part is you can't clear any of this out. You can in our console, you can clear it out, make it all clean, like you're starting from scratch. Unfortunately, you can't do it in the Python console. It gets a little confusing, but maybe later. All right, close this. So let's just copy these 2 lines here. Like I said, this is how every Python script will start in FLAC2D. We're going to import the ITASCA module as IT, and we're going to issue the command. We can say it.command because we just imported it as IT. Python reset state false. Resetting the state or setting that as false will allow us to run parametric studies, which we will do here. And I'll show you why that's so useful. Okay. And I will start running this, but let's get a little more code in here. All right, here's the main meat of the model. So let's copy all that. Okay, so what do we got here? We're issuing a command in Python, so it has to be it.command. That's how it starts. Using the triple quotation marks because it allows me to give a character return and then start typing more code, and then that tells Python this is a new line to execute. Okay, so all this stuff you've seen before. In Fish, it's much nicer to look at because the editor can highlight, things like this and make it look much nicer. But it's still the same. You got model large strain off. Some great quad. Fix that one. We have an elastic constitutive model. We have properties. And then my favorite face skin, and applying a few boundary conditions, setting the gravity, and we're just going to cycle once. You'll notice that maybe it does work. I was going to say you can't just execute bits of code. Maybe you can in Python, though. I don't think so. Oh, you can. Fantastic. Okay. One thing to note that in the Python console, I ran these 2 lines, but nothing showed up in the Python console. That's because the Python console is more for printing Python specific things. And the regular console, it will tell you, okay, kind of what's happened after you've just executed some lines of code. That makes sense. So it's told us, oh, here the Python state will not be reset on a model new. That's good. That's what we're going for. Okay, so then I'm just going to highlight lines 4 through 15, run that bit. All right, what happened? All sorts of things. Basically, like we said, we made our model. It's 10 by 10. We only cycled once. That's fine. And now I'm going to save my Python script, GG, and let's take a look at plot. Actually, let's just look at the model pane. There it is, 10 by 10. I skinned it so it has these zone face groups. And that's that. Well, I bet you that's super small for you guys to see. There we go. All right, this is kind of a tutorial model. This isn't anything that's really advanced. So it's just to get used to how we model in Python. Okay, so we basically just made a model using Python. Let's see what Python can do by using some of Python's utilities to query this model. So we're going to copy this IT zone count. And I could put it right here, and I will as well. Let's put it on line 17. So just judging from what this line looks like, it probably counts something, right? So within IT, there's a submodule called command, and that's how we process all commands. Within IT or ITASCA, there is a submodule called zone. And in that, you can get a function called count. And as you probably guessed, that's going to count how many zones there are. So let's run that line. See, in the console, it just spits out what you're putting in. It's like, oh, you ran this Python line. It's like, okay, so did you not do anything in the Python? That must have not worked. Let me try again. Okay, sorry about that. So in the Python console, I'm actually going to just paste in that same line and hit enter. Okay, I thought it was going to spit it out in the data file in the script, but it didn't. So that's correct. How many zones do we have? We have a 10 by 10 model, so there's 100 zones. And you might be asking yourself, okay, so where the heck do you even, like, how would you possibly know that it's it.zone.count? I mean, that's where you'll need to go into the documentation, much like with fish, and all the utilities. There's also utilities in Python. And the way we do that is, right now there's not a FLAC2D specific section, but again, anything in FLAC3D is currently in FLAC2D. And bear with me, this part of the documentation is a little obscure trying to find all this stuff, but I promise if you keep looking, you will find it. So the idea is that if you're looking for any of these functions, like what count, remember it was part of a zone function. So what you'll want to look for is the FLAC3D Python API. And it has basically everything that we can get out of Python that's in FLAC3D. There's one called zone. You click on it. There it is. ITASCA, it'll list all the different functions that are accessible in Python. ITASCA.zone.count. Get the number of zones. That's what it does. And again, apologies, this is all FLAC3D, but Python is the same in FLAC2D. Okay. Oh, here's one you're probably seen, I'd hope. Let's say Z. Let's copy both of these lines. Copy these lines, let's throw them. Now these I know I can put in my script and actually run it. Okay, let's run these two lines. Better work, dang it. Yeah, it did work. Okay, so the first line here, or line 17, I should say, is basically like I was just saying with the function count. This one uses the function find. It's going to find a zone with an ID of 1 and return Z. Well, what is Z? What I'm doing here is I'm printing it, and what is Z actually? Z is a pointer to a zone. So a pointer means it has data that contains the address and memory, and it looks like the ID contains a lot of different things. I don't know what that 100 is. That's interesting. Anyway, a lot of times old syntax for Python was this. Oh, it says, look, missing parentheses to call print. Did you mean print with the parentheses? Let's call it a bracket. So just remember that, because I know I've missed it a couple times. And it's going to get a little confusing in the console here, but the last thing I printed was right here. Unfortunately, we can't just clear it out. That's fine. Okay, we can get, here's a nice one. Let's copy that. Put that in the code here, line 20. Remember, Z is basically just a pointer to a zone that had ID 1. And now we're just gonna click that guy. Let's try and put it in the, sorry about this. I always get confused between using the console and the script. Okay, so if you put that line in the console, it'll spit out its location, its position. At 0.5, which makes sense because when we build a model, just a box like that, the first zone will have an ID of 1. Okay, we're at 4 o'clock. You can do all sorts of fancy things here. That's a fancy one. You can print basically a string of stuff. And it doesn't have to be a string. It'll convert it to a string. We're going to print zone, ID, put all that fancy stuff in there. It's just a way of like concatenating strings. All right, let's try this one. So you can do a loop. Just a good old-fashioned loop in Python. Let's copy that, paste it. All right, what we're going to do, the wording is a little strange because it's, volume, which is fine in FLAC2D. We have unit thickness, so there's still volume. First, we're going to initialize this variable to 0. You'll probably also notice that fish global symbols, or I should say Python variables or symbols, do not show up in here, unfortunately. This is only fish. Let me just get rid of it. So let's initialize that volume. I think always kind of confusing because it's like you do this and then nothing happens. So you can always check the volume. Square sum, what does that equal? 0. Good. All right, so now what we're going to do here is we're going to loop through the ITASCA IT module, and then through in the zone submodule in the list function. So this is a lot like fish, where we're going to loop through a pre-existing list of all the zones. And you can see the syntax is a little different for ZN. It's a little different from fish. And remember, for the for loop, it terminates with this colon. Anything spaced 4 spaces over or a tab, that's what will run underneath the for loop. Okay, let's do that. Okay, we got no errors. So let's try to print volume again. I just did the up arrow, returns the same one, and it's 100. Which makes sense. These are 1 by 1 quads. There's 100 of them, so I think that's about right. You can do other fancy things like this assert function checks it. It checks if the volume sum, which we just calculated, is equal to another way to calculate the volume sum. And yeah, it'll work. Okay, here's another way to try this. Take this line down here. Remember, I will go back to the start of the line, otherwise it would be executed underneath the for loop, even if there was a space there. Okay, so this is another way of finding a zone. It's much like zone.find, but this one, instead of giving an ID, we give a position space. So we're looking for a zone near 5.5, the middle of the model. Now, did anything happen? Remember, we can always check. Print Z. There it is. That's the information from the pointer. So an object, ID 45, blah, blah, blah. Okay. Now that we have defined Z, let's query some data or anything with the dot, I believe it is. If it's C dot position, Z dot whatever, that's what we have to put in the console. So let's take a look at the position. smack in the middle. Are there any properties? Yep, so there are. So this is nice here. This is actually returning a dictionary. The key is the name as a string, and then the value is the value that we assigned. That came from up here. Easy way to get those properties. All right, grid points. I'm not going to run through this in FLAC2D just because it's very similar to, we have all the zone data and we have grid point data. So it's accessed very much the same way, it.gridpoint.near, and then return its position. You can loop through all the grid points with the grid point list option. And then this is a function for grid points, and to actually find that, you would have to go again into the documentation. Remember, it's in FLAC2D Python. Look for the API, and then here's the grid point documentation. So grid point count. I wonder where the mass one is. I think it's in here somewhere, but regardless, it's in there. Okay, and that's grid points. Basically, an extra variable is you can give any kind of data to an object in FLAC2D. So you can say, for this particular zone, I want to give it an extra variable equal to a pore pressure. And then you can do that for all zones, and then you can color it or contour or color it by those extra variables. Basically, it's a way to give data to an object in FLAC2D, and that data can be anything of your choosing. We won't go through that too much, but just know that the same thing here is called Z. Remember Z in this point, in this line, we're finding a zone near the position 5,5, and we just set, it's called set extra. All right, groups. We can do grouping in Python. Let's copy these lines here. Let's just go. That's fine. We'll just keep it going. All right, let's issue these commands. Basically, you've probably seen these commands before. It's gonna create a group called lower from 0 to 5 in the vertical direction, and then upper from 5 to 10 in that in the vertical direction. Go to the console to see if it actually did anything, not the Python console. And yes, groups were assigned to 50 zones and another group to 50 zones. That's right. All right, so what's next? Okay, so now I think this just is the same thing, but it's loop for each zone in the list if the equals default lower, set the property, also set upper. Okay, that's just another way of using a loop to check for its grouping and then assigning some properties. I'm not going to go through that. I don't think I need it. Okay, let's go to the next slide here. Let's copy these few commands here. I'm not going to copy let's just copy the print, make it easier. Okay. So it just executes a few more commands. We're going to save the model state as before cycling. And then we're going to solve. Okay. So let's execute those few lines. Remember, basically, it'll take about a couple hundred steps because we just had basically a box equilibrating under gravity. Gravity is the only driving force here. So the whole thing is just moving in the vertical direction. And then we're going to define a couple variables here. Remember, this is using the submodule grid point and just finding one near those two positions. And then let's print those two. Let's see what they are, what they print out as. That must be a mistake. It didn't go down to the next. Ignore everything in there. What it printed was this vector here. It's interesting it didn't make a new line. It should have. Must be a bug. Anyway, it's printing the positions. Oh, excuse me. Sorry, it's printing the displacements. Yeah. So this GP top middle is a pointer to a grid point, and then it's printing the displacement .dsip. Which, if we wanted to go and look in our plot, which I didn't make a plot, make a plot. Add some zones, contour. You could find those grid points, and they should, sure enough, have the same displacement as you see in your plot. Okay, so that's all good and well. And then we won't go through this one, but there's more things you can find in the model using Python. Right here, the dot stress. So we can find a zone using zone.near, returns the central zone. And then once you have that central zone, you can use the dot stress or the dot strain functions, and that will return. Again, I think this is a tuple. Yeah, it's a tuple because it won't let you change the values inside it. Then this SYM means it's symmetric. If you wanted to copy and paste those in the code, you sure can. Okay, so let's move on to the kind of the point of using the model reset or setting model reset to false. So let's copy this input line up here. Let's take it into our model. I can't quite see the whole. Hold it. Scroll just a bit. Okay. All right, so what we're going to do here in this for loop is we create a list, just right in the for loop, for values. These are different moduli. So what we want to do is we want to run our model with these different moduli for the zones. So you can imagine doing this without using Python. And let's see, right here, every time you would issue a model restore, which is our the initialized state of our model, these values here would basically be cleared, because when you restore it, you without using Python, you're restoring it to this state right here. Sure, discard. Oh, don't worry about that. So it has no idea, if we weren't using Python, what this list is. It basically would give you an error when you're calling this value for Young's modulus, and you're like, this value doesn't exist. You restored it to a state where these values were never declared. But because we issued all the way up here at the very beginning, Python reset state false, these Python variables here, remember they're Python variables, it's a list of values in Python, they are not cleared. So we can restore the save state for cycling. We can give the Young's modulus for the zones. It will start as 69. and then 8E9, 10E9, 12E9. And then what we're going to do is, for each time we run this model with different moduli, we're going to get some data. We're going to look at, we're going to create a variable called vertical displacement, which will be the displacement in the y direction at a grid point near the middle, 5. And then what we're going to do is we're going to print some data. So this is kind of a fancy, this dot semicolon, this colon is a fancy way to use, I think, scientific notation on whatever variable you're passing. So in the first place marker will be the modulus. Second place marker will be the vertical displacement. Don't worry too much about the syntax there. Let's just run this. Let's see if it works. You could create a save state each time it ran. In fact, that would be ideal, is to create a save state each time it ran a different modulus, and then you can compare it that way. The point we're trying to make here is that because we issued the statement up at the very top that Python reset state is false, this data is not cleared on a model restore or a model new. So this allows you to run these parametric studies where you might want to look at maybe the cohesion or the friction, and maybe like 100 different values of cohesion and friction. Are you just gonna, like, you know, wait till the model's done, rerun it manually? No, you're gonna, what you really want to do is make a huge list of all those values that you want to investigate, and then you're going to want to make a loop similar to this and just let it rip, and then query all your data when it's done. So that's parameter studies. And we won't really go too much into this. This is just callback functions, just saying that we can use callback functions in Python just like you can do in Fish. So a callback function is, simply put, while you're cycling, a lot of times people will want to do something while cycling is going on. So you can write a function and call it a callback function, and during cycling, that function will automatically be called at the time step of your choosing, or the cycling of your choosing. So you can write a function that says return the stress at zone 1 upon every 10 cycles, and it will do that, because a lot of time during cycling, it's kind of you're whatever, like if you use the history or some other way to get data, well, not so much a history, but just keep it as that. You can use a callback to get some sort of value at every single cycle, or any cycle of your choosing. And you might be like, why does that even matter? Well, it matters because when you're changing some sort of variable while cycling, which isn't always the best thing to do, but sometimes what your modeling might require that. It's not used often. The idea is that histories kind of take care of all the data that you're trying to get from out of your model, but there might be some sort of crazy thing that you need to do that just isn't available in history. So that's why callback functions are so important. And all this is saying is that you can do a callback function in Python as well. All right, so that kind of sums it up for that part of the Python presentation. I'm going to take a look at this. We're not going to go through the array demo, just mostly because I definitely hit up on the arrays quite a bit in this. So we'll just stop it right there. So the main point is that you have all the functionality of Python that comes automatically with FLAC2D, FLAC3D, whatever. Do you need to learn all of the vast amount of Python, you know, what Python has to offer to create models? No, you don't. You really don't. Will there be something that Python really excels at? There might be. And usually what that is, it comes down to if you have a huge model, or you're trying to find a list of things really quickly, then you're gonna start to think, oh, Python might be a better application because you might be running your fish function and it is just spinning and it's taking hours to run. That happens. That's happened to me in many consulting jobs. And at that point, it's like, okay, let's turn our attention to the Python and see how it might help that particular problem. Some people code entirely in Python because they're so familiar with it. A lot of like new engineers in school today, they're like Python is their main bread and butter code. They know nothing but Python. So this way they can kind of pick up the code. They go straight to the Python script and they do all their modeling in Python, which is fine. But in my opinion, if you're really kind of want to know the fundamentals of FLAC2D or 3D, it starts by in the data file by knowing what commands to issue and by using fish. So that's my 2 cents on Python and FLAC2D. Very, very useful, very, very powerful, but never feel like, oh, I can't do something because I don't know how to do it in Python.